Okay, basic sprites. Here we go. All right, so what is a sprite? Right? A sprite is a 2D representation of an object. It's basically an object that we're going to put as an image that we're going to put in memory. It represents a type of object in the playing field. We're going to talk about that. Most characters, enemies, other objects, and we learned also that you can do this with buttons. You can create a button sprite. Okay? So this would be, and now we talked about some ideas for assignment number 3, and I know now that I've given you the option for assignment number 3 or assignment number 4. You're probably going to say, well, I never want to do assignment number 3, so. But here's a really cool thing you can do with assignment number 3. You can make it so that your button itself is a sprite. And then you can also make it so that there's a sprite that follows your cursor around. That's the size of a point, right? And then when you hover your sprite over your button, there's a collision, right? So you can do it that way too. You can use your sprite itself to collide or interact with other sprites, right? So that's one way you can use it to actually interact with buttons. So let's take a look at this basic sprite.py, and we're going to describe this in more detail as we go. I'm going to load this up in Aptana. So here's the basic sprite. Again, let's go over this code a little bit in detail. Again, we're using the IDEA framework. We're initializing it. We're importing, right? Here's a screen, 640 by 480. We're creating a class. Now, we talked about classes. Again, review for those people who are here. I need to use the class keyword. So here's my class, right? Class is just a blueprint. I haven't created an object yet, right? I'm defining the class. I'm making it a box class. And I'm also, what I'm doing here is I'm saying, in my argument for the class itself, right, I'm saying it's based off of the sprite class. This is not just the box class that I'm creating is a subclass of my sprite class that's built into Pygame. That's what this is. So when I go pygame.sprite.sprite, anything that I put in here in the brackets basically say this is a subclass, right? Now what I'm doing is I'm saying, well, I'm going to take this pygame.sprite.sprite and I'm going to initialize it. I need to use these two lines here in my constructor to initialize the sprite itself. Okay? I'm actually going to take the constructor from the initial Pygame class of sprite, and I'm going to call it when my constructor is actually called, right? So the parent constructor, all right, the superclass, which is the sprite that I'm actually I'm creating, right? I'm going to take that original constructor from the superclass and include it in my constructor from my box. That's what I'm doing here, okay? So I'm calling that superclass constructor within the constructor for my object. Okay, and then I'm basically saying my image, self.image, means I'm creating a new variable called image. It's going to be a class variable, and it's equal to a surface object. I'm creating a new surface object, and it's 25 by 25 pixels big. Okay, that's all I'm doing. 25 wide, 25 high. That's what this line is right here, right? This is my image, okay? So I'm defining the surface, how big my image is right now, okay? Then I'm going to convert it so it's compatible with Python and Pygame. I'm going to fill it with a color. In this particular case, my box is going to be red, right? RGB, fill it with a color. And now I'm going to use this new object or method. It's called the rect method, right? And basically what I'm saying is I'm going to when I use getRect, the getRect method is going to convert this thing, this surface. It's not just a regular surface now. I'm converting it into a sprite when I use the getRect method, right? I can also set the rectangle. That's what rect is, the rectangular object. I can set the center X and center Y component of my object. So originally my center X is going to be 0, which is the top left corner of my screen, right? Sorry, it's the middle of my sprite, sorry, and my rect center Y is going to be 200. Okay, there's reasons for this, okay? I also have a delta X and a delta Y. And if you go back to physics, I don't know if you guys remember physics at all, right? Huh? 55. You got 55 in physics? Yeah. Okay. So let's recant physics then. So delta delta x and delta y is the change in x and y. Delta is the change in your x and your y. In this particular case, my change in my x is 10 pixels to the right as I'm going, and my change in my y is 10 pixels downward, because remember, my x and y coordinates within my frame is to the top left. 0, 0 is my top left, and it's going to take the center of my object. I'm going to start off at 0, 200, 0 on top left corner, 200 down, right? And it's going to start making its trek to the right and down, okay? Now, I've got to create this update function for sprites. Specifically in Pygame, it's good to have this update method because there's other methods that call the update methods of sprites in Pygame, okay? So you need to have an update method in your class. So I'm creating a box sprite, again. I have my constructor, and outside of my constructor, I have a class method called update. What am I doing with this thing? I'm saying my center x is plus or equal to my dx value or my dy value every time my sprite updates, which means every frame I'm going to jump 10 pixels to the right and 10 pixels down. That's what it's going to do. It's going to be happening with when I call my update method, okay, whenever I call it. Here's my boundary collision, okay, here's my boundary checking. If the top of my rectangle, the sprite itself, right, is less than 0, right, and the left of my then I want to assign the left part of my rectangle to 0. Okay? Let's think about this for a second. Okay? And I also want to assign the bottom to 200. So I'm resetting it to where it was. So once I go to the bottom of my screen, I go whoop, and I set it back up to where it originally went.
Wait. How does that work?
Let's see. Oh, so it goes up. Okay, so it's going up. So it's going dx and dy. It's going to go 10. And what I'm doing here is actually, I know why I did that, because, sorry, here's the center y. I made a mistake here. The center y is minus equal, not plus equal. So it's actually going up. So even though I've said my delta y, my change in y is 10, I'm not telling it is it positive 10 or negative 10. In this particular case, I'm saying minus from my original starting position, which is 200, take away 10 pixels from it in an upward direction. Because remember, positive y on our graph, and I'll draw it out for those people who are here, right? So here's our canvas, right? Here's our canvas, and here's 0, 0, right? And 0 is where my object is going to start, 0, but I'm going to start here at 200 somewhere. Here's 200. There's my y. So this is where my box is actually going to start. There's my box. And then what's going to happen is I've got a delta x and a delta y of 10. Well, delta x is going to move it this direction. This is in the x direction. And then delta y is going to move it in this direction or in this direction. In this particular case, I've got a minus. If I move positive y, I'm going to move down here. If I move negative y, so I'm going to move up, which is counterintuitive to our thinking. When we say up, we think positive, right? But remember, that's only in a Cartesian coordinate system that starts at the bottom left-hand corner, 0, 0, which isn't true of ours. Our coordinate system and computer games generally, top left is 0, 0, okay, unless otherwise stated. Like, for example, in Cocos 2D, they do a Cartesian coordinate system, which is down here. Okay, but you can also readjust that for yourself. You can change the way things work for your game. You can make it so that you think the coordinate system is bottom left by reassigning certain variables and using other ones. You create your own classes for that. Okay. So does that make sense? So if I go at negative, if I'm doing a negative equals, or I'm incrementing negatively, I'm subtracting from my 200, which means this is why I'm doing this boundary check, because I'm saying if the top of my rectangle is 0, it's equal to the top of my screen. So if this goes to here, and over here, I drew it over here, right? Because it's going to continue to gain altitude, right, until this comes over here like this. So this is where I do my first boundary check here. So if this is equal, then what am I doing? I'm saying, well, I want the left part, this part of my object, to be over here again, and I want the bottom to be 200. So I'm going to go back down to 200. Here's 200 again. So I'm going to reset it back to where it was. And then it's going to loop again. It's going to start this whole loop again. And it's going to go here, do a boundary check, and then do this. And it's going to keep going like this. And it keeps doing that loop over and over again. So that's why the box keeps on it's going to keep on looping.
How do you make it bounce?
That's a different thing. You can make it so it goes in a different direction. And you can actually set other flags to say, if I've gone here, now I'm going to bounce in this direction, right? We're going to see a bounce. This first boundary check is just a reset. That's what this is. Or some people call it a wrap. Okay? So let's try this again. So let's see it. So here it is. So it looks like it's wrapping. You know, it's going up, and then it's almost like it keeps going in that direction. Now, if we want to change directions, right? So here we are in that direction. And I want it to go 10-10. Or maybe I don't want to subtract from my y at all. I just want it to keep going, right? So I've changed my delta y to 0, right? And my delta x is going to keep going across. So theoretically, now that I've made that change, it should go straight across the screen, okay? But now, we have to change my boundary collision, my boundary check, to say, well, I don't care if it's my top that I'm colliding with. I want to see that my right, and again, if you want to check what it is, you can go right.
What do you want to do, left?
Or left. Doesn't matter. If you do left, it's going to disappear. Yes. So if you do left, is greater than the screen width, right? Which in this particular case is 640, right? So let's just put greater than 640, right? Then I want to reset it to where it originally started, right? This works. So if I run this now, right? So here it is going across, and boop, there it goes again, right? So it does the boundary check. Now if I take that boundary check away, right? So I don't do that. If I just take this boundary check away, so I do this. I update my my variables here, right? And I'm subtracting 0. That's why it's not going up anymore, right? But if I take this part away, if I just comment it out, and the way I did that with Aptana was control and backslash, right? If I control backslash again, it comments it back in, right? And if I run it, I don't do a boundary check now. What happens? Whoop! It's gone into space.
Still going.
Still going. On the program, it's still going to go to infinity. Okay. But this is a good point. If it can go to infinity, that means that you can have objects that physically exist outside of a viewable area. Okay? This is a key point. So if I have an object that leaves my screen, it doesn't disappear. It exists in memory, right? Which means if my sprite image is the size of my screen or larger, all I'm going to see is this. This is my point of view, right? Anything that's outside of the screen can exist, right? But it's outside of my point of view, which means I can't see it. So when you're scrolling, and we're going to talk about scrolling next week, all you're doing is you're moving objects inside of my point of view so I can see it, so I can see the objects. Even if you create them outside of the point of view. For example, I've created a surface, my window is 640 by 480, but I can assign a window, or a sprite object that's 5,000 by 5,000, right? All you're going to see is 640 by 480, right? And then as you scroll, you're going to move the object, not the window. You're going to move the object, inside our window, right? And that's how you do that. You can imitate scrolling. So it looks like the background is scrolling. Where actually, all you're doing is moving an object. You're moving another sprite in the background. Okay, we'll get to that. Let's go back to this and just reassign everything the way it was. So it's 10. And again, we're checking to see if it's greater than 0. And it was the top. Okay, so just to put it back the way it was. So I've just changed a few objects. Oh, it's not moving anymore. Who knows what I did? Yeah.
If you switch the delta y to minus 10, it basically does that exact same thing except it goes basically down.
Yeah, you can do that too. Or you can just do plus equals to y, right? It goes the other way. If you go the other way, it goes this way. Yeah, there's all kinds of ways you can make it move, right? Let's go put it back the way it was. Dun, 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 dun. That's why I did greater than. I couldn't remember what I did. It was a greater than sign. Okay. And again, it'll just move in that direction. Now, one of the other questions I had was, well, what if I want to make it move faster or slower? Should I change my clock rate? And I told you guys this before. Here's my clock tick rate. Here's my actual game loop down here, right? I instantiate my sprite down here. First, I create my surface, right? Here's my surfaces for my background, my screen, and everything else, right? It's a yellow screen still, right? My box, when I instantiate my box object right here, I actually kick off this constructor method first, right? So this actually creates the sprite itself in memory and displays it, right? My update method, I'm going to use this other method called, I'm going to put it into a group. Okay, I'm going to create a sprite group called all sprites. Now why this is good, I can have 10 sprites and I can group them together. I compress them all into one group, right? Well, the thing with that is, if you notice, and this particular case I called it all sprites, but let's say I had more than one box object. I have 5 box objects and I want to group them together. Well, I can do that and I can call their clear method, if they have such a thing, their update method, and their draw method. Well, there is no draw method here or a clear method, but they do exist in the parent class for Sprite. All sprites have these 3 methods, clear, update, and draw, right?
Have update now that you made it?
It overwrites it. It overrides it. And you can override the clear method and the draw method as well. So it does different things.
So the Sprite has an update method built in.
But it doesn't do anything. It's a blank method. You have to override. That's the one method you have to override for you to use your Sprite properly. Because it's a template. The template's already there. The interface is there. You just have to change that. You just have to put the update method in there. Now, when you do that, look, I'm creating this all sprites group. When I create this group, I group all sprites. I can add more sprites, like box 2, box 3, however many boxes I want in here, right? And it groups them all together. And then when I run the clear method for all of them, as an example, or the update method, all of them update their positioning, right? So this is a great thing. So if I want to update more than one sprite at once, it's all over my screen, and they're all moving in different directions, they'll all update when I do this update method, if they're in the same group. Yeah?
Say if you were Sprite with your avatar,
Yes?
did you have to do all of the logic inside the update?
It depends on what you're doing with your avatar.
If you were just trying to make them jump, did you have to keep track of everything inside the update?
Yes. So what you're doing is, in the update, what you're doing is you're checking for boundary. You might check for boundary collision. You might be another method to check boundaries, right? So in your update method, it might call other methods inside your class that do other things, that check your boundaries, that do your physics, that do all those things that you're talking about, right? And it's all done with every frame, right? So depending if he's already in flight, maybe he's already in flight. The physics is happening. Well, maybe you can't make him jump anymore, right? Because it wouldn't be cool although some games allow you to. When you jump, you can jump again, right? But if you didn't want that to happen, you could disable those things by setting up flags. Jumped is true, as an example. If he's jumped or is moved, then you can't do certain things. So you can actually take control of the event handler and saying, I want to pause the event, my listening. I want to do anything until I've completed my move, and then I'm going to listen again. Okay?
Show us an example of something like a flag like that.
Yeah, we're going to see that as we move forward. We're going to this is the first example, right? Okay, so let's take it back to the presentation. So again, we talked about it being a visual representation. It has position and size attributes, the ability to move because you can move it with dx and dy values like we showed you, right? We can recognize collisions. Once you create a sprite and a surface, you convert a surface object to a sprite object, and you create your own class. As an example, you instantiate the sprite. It has the ability to detect collisions. Collisions is just any overlap with any other sprite. Okay? And like it says here, it's dynamic birth and death. You can create and destroy the sprites as you see fit, right? And it's reasonably self-contained, which means there's not going to be a big memory leak. It lives and dies. Once you create the object, it lives and dies, and it cleans up after itself in Pygame.
So how do you get sprites to generate in the game?
Okay, well we just showed you that, right? So here's the game loop, right? So here's my while loop, and inside my while loop, I'm going to do a bunch of different things. First, I'm going to instantiate my sprite. So this is where my sprite gets created.
Would you ever need to instantiate a sprite while the game is running?
You might. You might, depending on the type of sprites you're instantiating. I mean, I want to instantiate my box object within my game loop,
Like
right?
if your box breaks into 4 new sprites or something like that.
You could. I mean, anything's possible, but we're talking about what we're talking about here is hypotheticals. You can, depending on what you need, right? But remember, every time I reset, if I assign my box sprite again, what am I actually doing? I'm destroying it and recreating it, right? Because my box object, box is equal to box in capital B. I'm actually right there. I'm instantiating the object, which is a sprite subclass, right? So all I'm doing is I'm saying, well, assign my box sprite, assign it to my box variable, and create it. And when I create it, if it's something's already there, it'll just overwrite it, right? So you don't want. That's why it's not good to do that inside your game loop. It's good to do it, instantiate all your sprites and load them up ahead of time, and then update them in your game loop. Typically, it's how it's done. So here, the clear method is actually quite interesting as well. One thing I forgot to include. When you actually hit the clear method, what it does is it says, what's the surface that I'm updating? Here's my screen is my top level window, and my background is where, so both of these surfaces I'm clearing. I'm actually clearing the sprites for all those surfaces. I'm taking them away, right? And then what I'm doing is I'm updating them again, right? I'm updating the locations, and then I'm drawing them back to the screen. That's the surface object it's drawing to, the screen, not the background object, okay, which is the back screen is actually a top-level window, right? This would be your background, and the screen is actually the window around it with the title bar and the X, right? So the screen is where they get drawn to in this particular case. Okay, let's go back, and I'll get to the next example so it's more clear. We talked about objects and classes before, that they have properties. We have methods, and we have events, stimuli that responds to the sprite. And the constructor is this really special method that, again, inherits different attributes. For example, in our particular case, going back to this, our constructor object includes the constructor for the parent class sprite, right? So that means that anything that is working within that parent constructor also is included in our constructor. So when you instantiate a sprite, you're also instantiating this base class object, sprite object that exists already, right? Which you need because it also instantiates all the different objects and methods for that original sprite class. Okay? All right. And we're not going to talk too much about object-oriented programming because we've talked about it a bunch of times, right? But you can either use them or not. If you want to use an object-oriented model to create your sprite, you can. You can also do it without. I'm going to show you the object-oriented methodology behind it because it's better. Okay. We've talked about this already. It's usually placed in a sprite group for more power. You don't have to put it in a sprite group. You can control each of your sprites individually. The challenge is you're going to have to also update them and draw them individually. And that's the problem. You want to kind of, and I like to say this, have different groups of sprites that are related. So for example, if you had a bunch of aliens and there was one type of enemy, you might have an enemy 1 group, right? And you want to update all of them, right? And then you might have another type of group. For example, your background group might have a lot of background objects that are scrolling, right? Well, you want to update all of them, right? So depending on the order that you place your groups and how they're updated is sometimes the order they're displayed on the screen. So we're going to talk about layering and how we can layer sprites like that as we move forward. Okay. So again, just from a definition perspective, an image surface, we've seen that before when we load up the image. So here in this particular case, we can use the image load object to load up our image, whatever we want of our sprite. So you can define a sprite as a ping object, or it could be a bitmap object that you're going to load up as a sprite, or whatever. You're going to load that in by using the image.load method, and it's going to become the image. And then what you're going to do is you're going to convert it into the sprite itself. You're going to actually tell it the sprite size and position, right, by using the rect method. Okay?
Are they always rectangles?
Yes, which means, because again, if you think about it, We're looking at computers again, computer graphics. How can I define this in the computer? I can't. What about this other information over here, right? So typically what you have is, here's a rectangle, right? And you don't care about this information, the information outside of your sprite object. All you care about is your sprite object itself. Well, here's the problem, and it's a good observation you made. What if you have another rectangle that comes here, right? Here, and you have another object that's here somewhere, right? But they don't really touch. Is there a collision? Yeah. So there's ways of changing the boundaries of the rectangle, so you're not checking out here for the collision. We're actually checking in here closer to the sprite itself, right? Otherwise, you're going to get what we see we saw in MailPilot. The clouds look like clouds, but sometimes the ship might be close to the cloud, but not actually touching it, and there'll be a collision because the rectangles are crossing, right? So we're going to talk about collisions a little bit more as we move. Okay. So again, most changes to the sprite happen by manipulating its rect attribute. I think this is a good thing to notice. There's different positions, top, bottom, left, right, and so on. And I think you can do boundary checks depending on where you're looking at the sprite itself. Okay, so let's continue. You can add your own attributes. And this is where we added dx and dy to control motion, right? Again, we just call them dx and dy. They're just two variables that keep track of how far you want to change the y, the x attribute. And other custom attributes, which we're going to talk about. Okay? Two methods. You're going to need to create this constructor object or whatever, and the update, like we said. And the update is usually called once per frame, right? So if you have 30 frames per second, it's going to be called 30 times every second, which is a lot of updates. It's going to update that screen, so your sprite can move quite smoothly across the screen, so it doesn't look like it's jumping around too much. Again, you can create your own sprite methods here. This is what this is saying. For example, if you want to create a turn left method, you can say, well, I want all my sprites to turn left all at the same time. And if every sprite has a turn left method, you could use that as when you combine them into a group. You can use the same method. You can call the same method for each of the sprites. All right. So turn left or turn right, you can make it turn right, or fire missile. Create a fire missile method, and it does something. It actually takes another sprite, a missile sprite that you instantiate, and it might be, you might already instantiate them off the screen somewhere in your, outside of your viewable area, these missiles, right? Maybe they're circles or whatever. And now what you want to do is position it where your gun is, wherever the person's gun is. You know where the gun sprite is. And when you fire, you're going to actually show the missile. You're going to move that missile from outside of the screen to inside of the screen in our viewable area, and then move it in a particular direction, right?
Is that considered a hack job, or is that the normal way?
That's typically how we do it, right? Because you're moving things from outside of the viewable area. There exists, you instantiate all your objects first, you load them all up, and then as you load them, you call them, and you might have 10, 15, 20 missiles, or you might have a list of missiles that you kind of create outside of the viewable area. Or you can create them as you go, but if you create them as you go, the problem is that it could cause lag, because you're instantiating an object as you're playing the game, whereas it's better for you to preload or pre-instantiate all your objects ahead of time. So that's why sometimes it takes a little bit of time for you to load up your game screen, because you instantiate all your sprites, their objects, their backgrounds, all the methods that are involved there, and then you start playing the game. Okay. So again, we talked about creating a sprite object, a basic sprite.py. We defined the sprite class and the initializer or the constructor. We set the attributes, and we built the sprites upload update method, because we need that update method when we create instantiate the sprite later on. Okay. We're going to move on because we've talked about all this already. And we talked about the self parameter last class. Self, basically, you need the self parameter to when you're using classes, right? It basically says, when I say self, it actually means this class's property relating to the class or the object that you created. Okay, moving on. I'm just going to skip forward here because this is important. So normally, you extract the rect from the image attribute. So again, we've loaded the image up, and now we're going to get rect, right? And what we're actually saying is, so here's my image attribute. I've loaded it in, and now tell me the boundaries of my rectangle. That's what this image.getRect method is doing. So it's actually setting up the boundaries for your sprite, right? Once we know the boundaries, now we can do collisions, now we can do updates, now we can do all kinds of stuff, like the right side or the left side, right? Once you've done this self.image.getRect, it tells me that this is the top of the sprite, right? This is the bottom of the sprite, and it actually assigns, other methods to the boundaries of the sprite that you've created. And by the way, the sprite does not have to be a square. It can be any rectangle, an oblong rectangle. You can make it so it's like scrunched up. It can even be a pixel, right? As long as it's 1 pixel or more, it's considered a rectangle, right? So think about that. It means you can create pixelized sprites, which can help to create, or that size, which allow you to create more complex images and objects. Example is if you want to break down a wall, you have the Incredible Hulk sprite you have, and he's punching a wall. He's punching a wall. Well, how can you make that work so that the wall looks like it's crumbling? Well, there's 2 ways. Every time he hits the wall, he does a certain amount of damage you keep track of, and then you change the wall sprite so it looks like it's different. It's a broken wall. You just interchange that sprite so it looks like more broken, more broken. Or you can make it so that the wall is a collection of smaller sprites, like bricks, a brick sprite. And when you punch the wall, it moves physically the brick sprite with your own physics outside of the wall. It drops bricks outside of the wall, right? So it makes like if the wall is breaking. And if there's not enough support, and if there's less than 1 brick sprite that supports the other ones, these other ones fall, right? You can do that. You can make it as complex or as simple as you want. You can also combine sprites for your avatar. So for example, let's say your avatar typically is only 1 sprite, but if you want to make it so it's complex, like for example, it has a sword, and the sword is different than his legs in terms of collisions, or he has a gun, or whatever, you can add multiple layers of sprites to create your avatar, that they all move together in the same pattern. You kind of group them together, almost like my avatar group. My avatar group might be a bunch of different sprites that are moving together to make it seem that the avatar is together. Okay. Center X and center Y is basically the starting position of the sprite, and dx and dy values we talked about before. Okay, let's move on. There's different kinds of boundary checking that we can do. Okay, this is the instantiation we talked about before, and I'm just skipping ahead. And again, grouping, there's different types of grouping that we can do when we use sprites. You can group them together, like all similar sprites that you can group together, or you can group together every sprite, all different sprites, because you want to update everything at the same time, in the same frame that you're updating everything else. Or you can update them separately. For example, let's say if you want to update an object every second frame, you can do that too, if you had a need for that, right? So you wouldn't include it inside this object if you're inside this group. And again, the group, what it does is it compresses all the sprites, and they're all updated together. It basically references every sprite that you put in here. You can put as many sprites in there as you want, and you can update all of them all at the same time when you use the update function, the group's update function. And here we do. So we're doing actually the clear, the update, and the draw sprite method. So clears those 2 surfaces, the screen and the background. It removes them. And then update calls your update method, so it actually physically moves them. And then your draw draws all the sprite objects that are in that group back to the screen. And again, it clears the sprites. There's some fancy names here, like dirty rect updating, because basically what you're doing is you're getting rid of the sprite and you're putting it back, right? That's how we do a lot of the animation, right? We're actually clearing it away, we're wiping it off, destroying it, and then putting it back in. We're actually showing it again. Okay? And this is the group update that we talked about before. The draw method actually requires the screen as its only parameter, because that's where it's going to be drawing the sprites to. Okay. Flipping the display, we talked about this again. When you do a display flip, you're doing double buffering, so it makes it much smoother from a Pygame perspective when it comes to drawing or redrawing objects on the screen. Okay. So there's different objects we're going to talk about now. A circle that follows the mouse cursor. This is a sprite, and wherever I'm going to get my mouse X and mouse Y coordinates, and wherever I move my mouse, it's going to move the circle around. A square that pops up in a random spot. Okay, we're going to show you that. And a label containing text. All of these things can be sprites. So let's take a look at some of these things. So here's movecircle.py. Okay, let's go to that one. So I encourage you to go to our Aptana studio again for movecircle.py. So here it is, movecircle.py, and this is in the Lesson 6 code archive. Okay, so again, we've got another class we've created called circle, right, with a capital C. So it is a subclass of the Sprite superclass, or parent class, okay, just like we did before. Here's our constructor method, right, where we're calling, every time we instantiate an object that's of type class, of type circle, I mean, we also instantiate or call the superclass's constructor method, all right, which is this sprite init method. And then we're going to define the image object, our image as a 50 by 50 square, right? We're going to fill it with 255, 255, 255, which is all on, right? What color would that be?
White.
White. And then we're going to draw, when we call the this method, we're going to draw the sprite. We're going to use the draw method of my circle. Okay, because this is what it is, right? So we're going to draw a circle, and we're going to draw it a circle that starts off at with this color. All right, so 00 RGB, so blue circle, right? And this is, if you notice, this is our position and our diameter and the size of the circle itself, the border. And if you look at circle itself, it's a type of object we're doing in assignment number 3. Let me just go here and expand it. So again, if you follow this, the surface, right? It's going to draw the surface on this image that we've created, right? This image sprite. That's going to be our surface. Our color, the position, the radius, and the width of the circle itself. So it's going to have a 0 width. It's not going to have a border on it, right? We can put a border, but in this particular case, it doesn't include one. Okay. Okay, and then we're going to create this update method that says the center of my circle is equal to wherever my mouse position is. So this is my circle is going to move around where my mouse is. So mouse.getPosition is the method that allows me to track where my mouse is. Where is my mouse? Where is it? Where is it? And then it's going to draw it. Then, again, similarly to what we did in the last example, we're going to instantiate my circle sprite right here by making it equal to the circle class, right? And we're going to include it in an all sprites group. Here's the group. And we're going to include the circle, this new circle object we've instantiated inside the sprites group. And then we're going to clear it, update it, and draw it inside the loop. That's all we're doing. So what it will look like is this. So here's my circle object. This is a sprite, and I'm moving it around. Now, this is what I'm talking about. You could use the same methodology for doing your assignment number 3. Assignment number 3, remember, we hover over a button and we click on it. Well, when you hover over a button, you're actually, if the button is also a sprite, like I said before, and you may need to do this for your final project, once they overlap, the button and this circle sprite that's running around here, right? Once they overlap, you have a collision. And if you have a collision, you could effectively have a button push. You could check for if the left mouse button is pushed or not. Right? So you can create a much smaller circle, another sprite that's following your mouse around, that's invisible, a 1 by 1 or a 2 by 2 little sprite that you can't see, as an example. Or you want to make it, you can create your custom cursor, as an example, as you enter the canvas of your paint. And then as the cursor draws, you draw. And if you notice, this object moves inside of my canvas, but if I move my mouse outside of it, obviously it leaves my object in the same position where it was, but it'll jump to wherever my mouse is as I move it inside the window. So here it is.
You can follow your mouse around.
You've got to program that stuff, right? Because right now, all it does is detects, it only draws it. Here's my update function. My center of my circle is this where my mouse is, right? Well, my mouse can't be tracked when it's outside of my screen, right? Because it's outside of my game world, right? So in order for me to track where it is, I've got to send information back into my game world somehow. So it's not an easy task, that's what I'm saying. But there's methodologies, things you can do around that as well. So move circle.py. Okay, let's go back to the... All right. And I've kind of gone over the class. Let's do the label demo.py one. Again, this is just another label. So here it is. And if I run it, I've got a bunch of labels. I've got this label that's fixed, right? I got there's another label. These are all sprites, by the way. And look, this is a label that changes according to where my mouse position is. It actually shows me my mouse position. So I'm moving my mouse around. But if I leave the screen again, and actually detects button presses too. Look, here's a button press, right? Any kind of button press, right? So here's a scroll. I'm actually scrolling with my mouse. It detects that as a press. Same thing with my other buttons that I have on my Republic of Gamers mouse, right? It has different buttons, right? So it's going to pick it up. If I move outside of my screen though, and I move my mouse around, it doesn't care because I'm outside of my game world, and it doesn't pick up where my position is. It only picks up the position of my mouse when I'm inside of my game world or inside of my canvas. Outside, it doesn't exist. Okay? So how do we do that? And again, really quickly, we create my label class. We instantiate it. We initialize with a constructor. We call the sprite constructor. We create the font as we did before. We define the center as being 320 by 240, the center of the sprite, right? And then when we do an on update, we render the font, right? We're rendering the font at a specific location. We're making it we're converting it to a sprite, and we're setting up the center wherever my center exists, okay? Which is 320 by 240. Here's my tuple for my center, okay? Then I've got a bunch of labels now I'm doing, and they're all the label sprite, if you notice. Take a look. So now I'm instantiating multiple sprites from the same class. So here's my label class I've created, label, right? And I've got 3 different sprites. I've got my label 1, my label 2, and my label event sprite. And now I'm updating them all within that sprite group, right? So here they are, label 1, label 2, and label event. And they're all being updated all at once. The one thing I am doing is I'm saying, hey, let's set up the label text, the text field of the label, to hi, I'm a label. And then the other one is, here's another label. And then I'm also giving it its own custom center value, right? Because I have a center value right here. It has a default value of 320 by 240, right? But all I'm doing is I'm overwriting that value again, right? Because I have this center value, and this text value is a property of my class. So each of my objects also has a .text property or a .center property, and I can assign those as I go right here. Right, they're available. Those properties or variables are available outside of my sprite, inside my object here. Okay. Inside my game loop, though, what I'm actually doing is I'm updating my event label. Here's my event label itself. I'm updating it. And I'm updating with my mouse position, my mouse X and mouse Y values that I'm getting from this mouse.getPosition method, right? Because my mouse.getPosition method shoots me back 2 variables, mouse X and mouse Y. Comes out of it. That's what it returns, right? So you always have an X and Y coordinate. And then I'm updating all my sprites and clearing and redrawing them every time I do an update. Okay. All right, so we talked about that. The other one I wanted to look at is square, just the boxes. Now this is where I think Stephen, you said it. The boxes. If I want to put random locations for my stuff, how do I do it? Well, if I go to my boxes demo, so boxes.py, let's pull that one up. And again, let's take a look at this closely. Here's my class, my square class. So I've got 3 objects: square, circle, and label right now that I've defined, right? And here, what I'm doing is my constructor. Again, I'm creating the surface for my object. But guess what? I'm using a random range now. Right? Here's my random, and I'm creating a range between 10 and 50 pixels. So my square is going to be randomly sized when I instantiate it. It's going to have a random area, okay, every time I instantiate my squares. I'm going to fill it with a color, and I'm going to pass the color into my constructor, into my sprite. When I create my square, I'm going to pass it a color. It's going to be required, right? I'm going to update it. I'm going to create a random location for my object. When I instantiate my object, my center X and center Y are randomly determined. And it's going to be between 0 and the screen width and 0 and the screen height for my X and Y coordinates. So a random location and a random size for my object. Right? So here's my box, and guess what I'm doing here? I'm saying my boxes is actually, here's really something really neat. I'm creating an array of boxes. Right? And what I'm doing is I'm saying, well, you know what? I'm going to append a new square, right, object that I'm going to instantiate into my box list. I'm going to create a list or an array of objects, and it's going to be as many objects as there are colors. So 32,600 colors or whatever it's going to be. I'm going to have that many boxes on the screen. Okay, that's what this is going to do. And then I'm going to update all the sprites at once. This is where the update function is awesome, right? Because now I create my boxes, which is a list. This is how powerful this is, inside my group, and I'm updating all of these sprites all at the same time, every time that I have an update. Let's take a look at that, how it works. So here's random boxes, boom. And it appears these are, you know, for one box for each color, right? And randomizes all the size. If I call this function again, or do this again, it'll be a different picture. Let's try it again.
Why is there so much white?
It looks like it's white, but it's very close to white. Remember, there's that many variations in color, right? So let's try it again.
I'm just surprised at how much white.
But it also looks like there's a lot of blacks and browns and stuff because you can't differentiate between one type of brown and another. Our eyes aren't sensitive enough, especially us being guys. We only see in 16 colors. Come on, let's face it, right? Girls see more colors. But that's just me. All right, so let's go back. So that was a kind of a neat example of how you can create a list of sprites. Remember we talked about lists, how powerful they are. That you can append more things on there. Imagine if you create a bullet list. And now I create a bullet sprite class, and I instantiate it as an object. I can load the bullet as an image, or I can load it in. I can create a circle, a black circle as a bullet, whatever, however simple I want to get, right? And I make as many bullets as I need. 100 bullets, 1,000 bullets, whatever, and I instantiate them all. If you saw here, there's thousands of boxes that I just loaded in, and I displayed them all at once, and it didn't take long, right? So I can literally, outside of the screen here, I can have a bunch of bullets that are already instantiated, and all I'm doing is whenever I fire the button, whenever I click the mouse button, I'm actually saying move him wherever my avatar is, like wherever his gun is, as an example, and you might have a specific place for his gun. Move it there, and then move it out as, in a direction that he's pointing, which we're going to know how to do later on. Yeah.
I have a question. Talk about all these sprites in this group.
Yeah.
How would you interact with something individually?
You have to create its own. It's going to be on its own, right? So if you put it in its group, you update everything all at once, right? But that being said, you can still have custom properties for a specific object that you update before you do the update, the group update, as an example, right? So you might have multiple things moving at the same time, but you also might have specific things moving separately, and we'll see that as well as we move into MailPilot. Okay, let's try creating a collision objects.py and use call.py. So here's collision objects.py. This is something new. And if you look at it, we have a square object, the circle object that we defined before, and the label object. Right? So that's all this is. This collision objects.py file is actually just a set of classes that we're going to call. Okay? And then we're going to use collision objects because what we're going to do is we're going to import the other file that I have, which is called collision object. So when you import your own file, right, that you have a bunch of classes that are useful, like we made a circle, a square, and a label, and you want to import them into your code, you're literally cutting and pasting code that you can't see. When the file is actually running, when you're in run mode, you're actually cutting and pasting that stuff inside your file. And the only way you do it is that file that you're importing, you have to actually tell Python where to get it, right? And you exclude the .py ending, right? So for example, my collision objects I just loaded up is right here, and it's called collisionobject.py, but I'm not mentioning, when I'm importing it, I don't put collisionobject.py in here. It doesn't know what that .py method is, right? So that's what you do here. So now I've included those three things, circle, square, and label, and I'm using it in my useCall.py program. Okay? Now this is really cool. If you notice how it says collision objects label, right? Because my label is defined, take a look up here guys, my label is defined in my collision objects file, I have to use the .label accessor method, right? Because my label doesn't exist inside my file. It's an actual class that exists outside of my file in something that's called a file that's called collision objects. So therefore, I have to reference that object right here, unless I rename it, by the way, and there's ways of doing that, right? To rename it to, let's say, co dot whatever. You can rename the object to whatever you want, right? And we'll talk about that later as well. Short forms. Circle, label, and square they're all collision objects label, circle, and square. They belong in the collision objects file, therefore you have to reference them with their file name. Okay? And then what I'm doing is I'm instantiating these objects. The label, the circle, and the square are instantiated. I put them all inside the same group, and I update them. So let's take a look at that. So here's my circle, and as I move it, if you notice, it moves behind the square. Why does it move behind the square? Anyone? I know we're running out of time here. Yeah? No, there's no set index because of the way we've defined circle, square, and label. The way we've grouped them together is it layers them that way. So circle is first, the first one is the bottom object, then square is the one on top of that, and label is on top of that. Right? So there's another one we can use called ordered updates, which we're going to see. It's another grouping class that we can use, and it allows you to order them exactly the way you like. Okay. How do we detect collisions? Well, let's look at sprite.py for that before we leave. I know we're running a little late today because we talked a little bit about our assignment 3 and assignment 4, took a little bit of class time there. So again, we're using the collision objects class file we created, right? And this time what we're doing is, during our update, right, we create a circle and a square, and we put them all inside a group, right? And then what we're doing is we're doing a check, and we're saying this: if circle.rect.collideRect with square.rect, because both of them are rectangles. So if my circle collides with my square, then change the label output of my text, my label, to collision, right? Otherwise, there's no collision. So every time I do my update and I move my thing away, it's going to either say collision or no collision. Okay? It's also going to make a sound. It's going to make this woohoo sound, right? It's going to play my woohoo sound every time I make a collision. So as long as it collides, as long as they're intersecting, it's going to go woohoo, 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 and it's going to keep doing that over and over again. Try it out on your screen so you can see what I'm talking about. You won't hear it, what I'm doing. But let's run it so you see. So here's my circle. I'm going to collide it with my square, and it's woohoo-hooing in my ear. Woohoo-hoo. But if you notice, collision, no collision. Collision, no collision, right? And if you notice, again, the circle is underneath the square. Yeah.
If you put the very edge, bottom left-hand corner of the circle, towards that square, will it
Yes, because the reason why, again, because these are both rectangles. If you notice here, it'll show me a collision here, see? I talked about that over here, because the two rectangles are intersecting, not necessarily the object, the image that's inside of them. So we have to modify that. As we go forward, we're going to have a method where you can reduce the boundaries, the boundary checking of your object. When you do collisions, you can make it smaller, so that your boundary is closer to the object that's inside. Yeah, you're first.
Only rectangle collision?
Yes. Yeah. Well, there's other methods. If you look online, there's other methods that you can do the object itself.
Even if you did change the boundaries, wouldn't you still see the square white rectangle showing up sometimes?
No, because you can make it invisible. And right now it's not, because the background is white, but we can make it so that the background is transparent.
Is that by using like making the image itself transparent, or
You can do the image, and you can also make it so that it looks for a specific pixel, like any white pixel inside that surface is transparent. You can say that's transparent, and it won't display that pixel. Any white pixel, as an example, right? We'll show you that as we move forward. Okay, so let's go back really quickly. We have about 5 more slides, really quickly. And then I've kind of covered everything. So that's an example of how we were able to check if it's colliding or not. And if you notice, it's that Sprite collide. We're checking that Sprite collide methodology right here. So we're saying collide rect. Is it true? If it's true, if the circle collides with the rectangle, with the square, then it's true. Otherwise, it's false, and it goes to no collision. Okay? Here's another one. You can check whole groups to collide with each other. Okay, so let's try spritegroup.py to demonstrate that one. Because remember, a sprite group is a compressed group of sprites, and you can use other methods to check for collision. So here, what we're saying is my square is it's a square of a certain size. I'm going to make more than one square. I'm going to make a bunch of squares, 10 squares that I'm going to create, and I'm going to create a circle. But what I'm going to do is I'm going to have 2 groups: my basic sprites, which is my circle, and my square group. So I have 2 different groups, and now when I check, I'm going to check for collisions between those 2 groups, not individual squares and circles. So this is an example of I have my avatar and I have a bunch of clouds, and I'm going to check if my avatar and all its related sprites collide with my clouds, any cloud, right? So this is how you do it: sprite collide, circle, and with this sprite group, this whole sprite group. So I'm checking my circle with the whole sprite group. Let's take a look. And if you notice, I have to individually update different groups. I do 2 clears because one of them clears my square group and the other one clears my basic sprites. And the other one updates my square group and the other one updates my basic sprites. So I have to have different updates and clears because I have 2 different groups going on, right?
use the flip instead of the...
Here?
Oh, there it is.
So here's my bunch of squares. If you notice here, I've got a collision. See that how the circle now is layered on top as opposed to underneath, and that's why it has that white border. Because truly the circle, even though we're seeing a circle, it's still a rectangle, right? So it's colliding there, it's colliding here, it's colliding here, it's colliding anywhere where there's a square, right? Here's all these collisions, but over here there's no collisions. But here, if I pass through, right, chances are there's going to be a collision, even though there's no physical collision with the circle, as you can see. Okay? So again, kind of neat that you can do that with multiple groups. And we talked about this. Bounding boxes is the box that's outside of the area. And what you can do is you can change the bounding box of your sprite so it's smaller. That's one way of doing it. And there's other methods if you want to look up sprites. Okay, and this is the example that I was talking about before. You have a ship that looks like this. As it moves in this direction, if you notice, the bounding boxes will collide even though the ships don't show a physical collision. So there's methods to overcome that, right? And you can do things like set the color key. Let me show you the color key. Here's color key.sprite. And we're running right to the end today. So if you notice, here's no collision, right? And right here, look, I'm right to the edge, right? And there's a collision. But if you notice, if I go on top of it, on top of the object or below it, the color key is set to white, as an example, so you can't see the circle, the edges of the circle. Still, the rectangle is still the bounding box, and that's why you have that weird collision. Okay? So I created a new circle class based on the original circle. I'm actually subclassing the circle here. So it's a subclass of a subclass. So this is a great example of inheritance here, right? And then what I'm doing is I'm changing my color key to white. So anything that's white, I'm saying that color is transparent. So white will never show up. If my the surface object that I'm layering the circle on top is white, and I say my color key is white, white will never be displayed or drawn. So you won't have that square border that we had before. And that's what that does. Last slide. Read the chapters in the book, which doesn't exist. At the end of the day, again, from a recap perspective, two things I want to say before I let you go, a couple thoughts. Assignment 3 and Assignment 4. Choose which one. Its due date is the same as Assignment 4. Like I said, I'm going to put an announcement on Blackboard to that effect as well. So people who aren't in the class and missed class today, they're going to have it, right? Please pay close attention to this particular lesson because there's a whole bunch of information here about sprites that you're going to need to understand when you're working with sprites and for your game, okay? I would encourage you to fool around, like literally try and create some different sprites, load up some ship images and stuff. We're going to do that next week as well, right? And manipulate these sprites as we move forward to try and get more familiar and comfortable with some of these methods, okay? Otherwise, I'm available via email, and again, there's going to be, we're going to encourage students to volunteer as peer tutors. We're going to have a couple probably of volunteers, I'm guessing, that are going to be for people who need help, okay? Otherwise, we'll see you next week.
Also, if you need help, go down there too.
If you need help, that's right. If you need help, you go to K105.
103.
103? Is it 103?
K103.
K103, you go to if you need help, and they'll set up a tutor with you. Thank you.
Well, I made that correction because I told her, I was like, yeah, so, because Ross was talking about K105, and she's like, no, it's 103.
All right.